Hi everyone, welcome to the part 2 of the solver. So clearly we cannot put just any values in our decision variable cells, but only the ones that correspond to feasible resolution. So it is time to specify the constraint of our problem. The first constraint is a budget constraint. The budget value is 195 million is stored in the cell D15. We want to make sure the sum of a decision variable, that is the sum of the spending amounts for the products into market, does not exceed this value. My plan is to put the value of the sum into the B15, sum of our four decision variables. Currently it is in 130 million. Later, when we will ask the solver to find a best advertising policy, we'll also instruct you to make sure that the value in the cell B15 never exceeds the value in the cell B15. I put a corresponding sign in the cell C15 just to embellish the spreadsheet. The sign will not play any role in the optimization. It's just a visual cue, so you don't have to use it if you don't want to. Okay, the next constraint is the one that requires Hudson Readers to generate at least 3 million in the net sales increase in the Indian market. The limiting value 3 million is stored in the cell G16. So in the cells B16, we calculate the net sales increase in India resulting from the decision in cells B11 through C12. This increase can be calculated by multiplying the advertising spending on the standard product in the Indian market by the respective advertising effectiveness value, and do the same for the enhanced product in the Indian market, and then add those two products. This sounds like a sum product, and that's what we are going to do. Sum product of spending in India, and both types of product times the corresponding effectiveness coefficient. Now let's do the same thing for the constraint them to the on the minimum net sale increase in China. We put the corresponding formula in the cell B70, some product of spending in China multiplied by respective coefficient of self effectiveness in this market. Now the last constraint tells us that the total net sales increase the enhanced version must be at least 80% of the increase of the standard version. So in the cell B18, we'll calculate the total net sales increase for the enhanced version. As before, we'll use the sum product formula. So it's the sum product of spending on the enhanced version across the two markets multiplied by respective coefficient. And now in the cell D18, I'm going to put the formula for the 80% of the net sales increase of the standard version. So is equal to 0.8 times sum product of spending on standard version across two markets multiplied by two coefficient. The constraint that will pass on the solver will be that the value in the cell B10 can't be lower than the value of the cell D18. We can put the corresponding visual cues in these three cells. Okay, we are now ready for the solver. So we got to data, click on solver. The solver parameters dialog box pops up. Here, the set objective part, we click on the cell selection tool and choose the cell A6 to represent our objective function. Solver can maximize or minimize the selected objective, or it can find a combination of decision variables to produce the required value of the objective function. Here we are maximizing the total net cell increase. We select max. Now we need to communicate to solver where decision variables are. So we use by changing variable cell selection tool to point this over to the cells D11 through C12. Final constraint. Here we use subject constraint part, and we specify the budget constraint first. B15 less or equal than D15. By the way, we could specify constraint by using equal signs, a greater equal sign, so we can force decision variables to take integer values or binary values 0 1, or we can ask over to find a solution with all decision variables taking different values. Next, we need to add constraint on same reasons India, China, and also enhance versus standard version constraint. So all of those three cells should be greater or equal than values in these three cells. We click OK, and now we'll see all the constraints have been communicated to Excel. What is left in adding the constraint that tells the solver that our decision variable must take non-negative values. Solver offers a convenient way of introducing non-negative to consider for all the decision variables at the same time. All we need to do is to check the box, make all constraint variables non-negative. Next, we need to select a solving method. Solver offers several choices here: GR nonlinear, LP, and evolutionary solver. I would set the solver method to as GRG nonlinear. The solution method is very general and will allow you to work with many different kind of models. A couple of things to remember: since GRG nonlinear is a great method of solving optimization problem, it will try to find the best solution for any model you formulate. However, it may not always be able to guarantee that what it finds and gives you as a solution is actually the best possible solution. In addition, the solution that the GRG nonlinear method produces may depend on the initial values and decision variable cells. So when optimizing using this method, run it several times with different starting values or decision variables to see if you can improve the objective function value. Okay, let's run the solver. We need to click the solve button and also make sure the solver found a solution is displayed in the dialog box that appears. Here we have the optimal solution. We'll discuss it in a couple of minutes, but first a few words about solver messages. At this time, the solver came up with a message: solver found a solution. This is the message that indicates to us that everything went according to the plan. However, it is possible to get other not so encouraging messages. For example, suppose we forgot to include an important constraint. Let's go to solver dialog and remove all constraint. If we solve our model now, the solver comes back with a complaint. Objective sell values do not converge. This means that the net sales increase in the model can be become infinitely large. When you see a message like that, it probably means that you forgot an important constraint. Okay, let's put back our constraints. Another possibility arises when you overestimate your model. In other words, then there's feasible solution to demonstrate how can this happen. Let us reduce the advertising budget to 180 million. This was the previous solution. Let's go here and change the budget to 180 million. Where when we are around the model now, the solver says that could not find a feasible solution to summarize. When you miss a constraint or reconstraint that contradict to each other, it will get one of those messages, and then you have to go back to the drawing board to see how your model should be corrected. Here's the solution to Hudson Regis problem. We have stored the details in the Excel file with the same name as the solution multiplies. The entire advertising budget is used up. This, of course, is not surprising. Given advertising alternatives, the company has the maximum sales increase it can achieve using the budget of 195 million. In other words, the best return on advertising spending the company can achieve 7.3 divided by 195 is around 3.8. The major portion of spending goes to advertising of the enhanced version in China. They advertise in China with a return of 3%. So an only minor portion is devoted to advertising channels with high return of 4% and 5%. This is what happens if the problem is resolved with a slightly higher value than the advertising budget, namely 200 million. And you can read that. Of course, we can systematically change the budget value to see how it impacts the optimal net sales increase value in the budget allocation. We can do it manually, or we can do it more automated fashion using an Excel add-in solver table that you can download using this link. The results are represented in the sheets called analysis and Hudson Reader spreadsheet. For example, we can tabulate the values of the optimal net sales increase as a function of the budget value to see how far extra advertising budgets go. In this case, the extra budget brings extra net sales increase at the rate of around 4.2 cents on a dollar. As the budget increases in the range of budget values, we looked at from 195 million to 170 million dollars. This rate drops to around 3.9% of dollar. As advertising budget increases, its allocation in percentage terms also changes. And in particular, the function of fraction of the advertising of the enhanced version in China remains stable and high, around 56.7% across the range of budget values we looked at. While advertising the enhanced version in India remains unattractive as far as the standard version is concerned. Its advertising shifts from China to India as advertising budget grows. In the session, we have solved our first optimization model in this course, and there's more to come. So far, we have been dealing with the setting outcome of any potential choice is highly predictable. In the next session, we'll continue working optimization toolkit, and we'll look at an example where a decision maker uses a simple measure to evaluate future uncertainty. See you soon. Thanks for watching. Okay.